All right, ladies and gentlemen, the parabola. Okay, so section 7.3 is the order of business. All right, and basically, what does a parabola look like? Well, a parabola is kind of like a smooth shaped graph. This parabola here is opening upwards. In general, you have a focus point, just like you had two focal points for a hyperbola and an ellipse. You have one focal point for a parabola. And you also have another facet of a parabola called a directrix, which is just a line. And the idea behind this is that if you choose any point on this parabola, any arbitrary point x, y, and compute the distance between that point and the focus point, call that distance d sub 1, and then also compute the perpendicular distance between the arbitrarily chosen point of the parabola and this line called the directrix, call that distance d sub 2. As it turns out, ladies and gentlemen, these distances are equivalent to each other. Okay, so no matter where you move this point on the parabola, the distance between the focal point and the point on the parabola and the distance between the point on the parabola and this directrix, the perpendicular distances, those are equal to each other, these distances here. This distance equal to this distance. All right. The general form equation for a parabola is either going to be ax squared plus cx plus dy plus e equals 0, or you could have ay squared plus cy plus dx plus e equals 0. So this is the general form equation for a parabola. The first parabola pertains to parabolas that open up or down. So this would be the up-down variety. And the second general form equation pertains to parabolas that open to the right or the left. All right. All right, first of all, let's look at the up-down parabolas here. Those are parabolas that open up or down. In general, the equation looks like this. Right. Notice the x variable is being squared, but the y variable is not being squared. The y variable is to the first power. This is called a standard form equation. Standard form equation for parabolas that open upwards or downwards. If this number p here is greater than 0, then the parabola opens upwards. So the graph would look like that. If this number p in the equation is less than 0, meaning negative, then the parabola opens downwards. Regardless of whether your parabola opens upwards or downwards, there's going to be a point of interest on the graph called the vertex point. If the parabola opens upwards, the vertex point is going to be a minimum point. If the parabola opens downwards, the vertex point is going to be a maximum point. These points are called the vertex point. So that's the vertex point. And to find the vertex point of the parabola is pretty simple. You just read it right off from the equation. It's the ordered pair HK. Recall HK, ladies and gentlemen, was the center of a circle. It's also the center of an ellipse. It's the center of a hyperbola. And now it's the center of a parabola. It's the vertex of a parabola, rather. That's the vertex point. All right, specifically, let's look at a parabola that opens upwards now. Any questions about any of this on your? By the way, to go from general to standard form equation, we're gonna have to complete the square. Here we would have to complete the square on x. Here we would have to complete the square on y. Okay, so the good news compared to the ellipse and hyperbola is you only have to complete the square on one variable instead of two. That's a little bit of pressure off of us. All right, let's look at the parabola that opens upwards. The parabola that opens upwards, ladies and gentlemen, is going to look like this. The minimum point or low point on the graph is called the vertex point. That's HK. That is the vertex. We have a focal point here, a focus. We have a directrix. In this case, for a parabola that opens upwards, our directrix is going to be a horizontal line called the directrix. Now, the distance between the focal point and the vertex point is that number P. That's also the distance between the vertex and the directrix. This vertical line here that contains the vertex point and the focus point is called the axis of symmetry. So this line, this vertical line, is called the axis of symmetry, because the graph is symmetric with respect to that vertical line. Notice the axis of symmetry is perpendicular to the directrix. All right. You also have an interesting little line segment here that contains the focal point and also contains 2 points on the parabola. This little line segment has a name. Don't laugh, ladies and gentlemen. It's called the latus rectum. I kid you not. It's called the latus rectum. I did not make that up. This little line segment that contains the focal point and 2 points on the parabola is called the latus rectum of the parabola. I don't know. That sounds kind of carnal, doesn't it? The latus rectum. But hey, that's the name of it. Now, the distance between the point on the parabola and the focal point that lies on the latus rectum, that distance is 2 times the absolute value of P. Likewise, that is this distance here, 2 times the absolute value of P. Okay. Now, we know that P is greater than 0 because this parabola opens upwards. We know the standard form equation for this parabola would be x minus h quantity squared is equal to 4 times P times y minus k. That is the standard form equation for a parabola that opens upwards. And notice that number P is positive. All right. The focus point would be the ordered pair H comma K plus P. That's your focus point up here. Your directrix is a horizontal line, and the equation of the directrix would be y is equal to K minus P. That's the equation of this line here, this horizontal line called the directrix. The vertex point would be the ordered pair HK. The axis of symmetry is this vertical line that contains the focal point and the vertex point and is perpendicular or orthogonal to the directrix. The axis of symmetry is the equation x equals h. That's the equation of the axis of symmetry. It's a vertical line. Notice the directrix is a horizontal line. Okay. Ladies and gentlemen, the focal diameter There's also something called the focal diameter. The focal diameter is equal to the length of the lattice rectum. And the focal diameter is always 4 times the absolute value of P. Okay, that's the focal diameter. So the focal diameter is the length of this lattice rectum up here. Any questions about all the terminology surrounding a parabola that opens upwards, ladies and gentlemen? All right. That's for a parabola that opens upwards. So we got that there. Okay, that's for a parabola that opens upwards. How about a parabola that opens downwards? Well, now the vertex point is rendered as being a maximum point on the graph. This axis here is, of course, the axis of symmetry, because the parabola is symmetric with respect to with this vertical line. Your directrix would be out here. It would be horizontal. Got a focal point here, focus. This distance, the perpendicular distance between the vertex point and the directrix, is that number P. That's also the distance between the focal point and the vertex point, P. Standard form equation for a parabola that opens downwards is x minus h squared equal to 4p times y minus k. But what's p in this case? Since the parabola opens downwards, p would be what? Anybody? P would
be a negative.
Negative. So that number p is negative. What else? Well, we know the vertex is hk. Reader, you can read that right off from the equation. We know the focal point, the focus would be the ordered pair h k plus p. The equation of the directrix, since it's a horizontal line up here, is going to be y equal to k minus p. The axis of symmetry being a vertical line is x equal to h. And the focal diameter, again, the focal diameter is going to be 4 times absolute value of p. And of course, you have this line here that goes through the focal point. It's called your lattice rectum here. Its total length is 4 times the absolute value of p. And so the length of one of these half line segments of the lattice rectum would be 2 times the absolute value of p. Okay. That's for a parabola that opens downward. Now, for a parabola that opens to the right, now you could have a parabola that opens to the right in the xy plane. Looks like this. You got a focus point right here. Now your directrix, ladies and gentlemen, would be not horizontal, but it's going to be vertical. This is your directrix here. This is your axis of symmetry. Vertex point. The distance between the vertex point and the focal point is still P. Nothing changes there. And that's still the perpendicular distance between the vertex point and the directrix, still P. All right. You still got your latus rectum here, and it runs right through here. Here's the standard form equation for a parabola that opens to the right. It'd be y minus k quantity squared is equal to 4p times x minus h. Notice now for the parabola that opens to the right, the y variable is being squared. And if a parabola opens to the right, ladies and gentlemen, p is greater than 0. This number p is greater than 0 for a parabola that opens to the right. The vertex point is still going to be hk. Nothing changes there. The focus is going to be the ordered pair h plus pk. The equation of the directrix being a vertical line, the directrix is going to be the equation x equal to h minus p. The axis of symmetry, since it's a horizontal line, would be the equation y equal to k. Focal diameter is still the same it was for the up-down parabola.
Could you move the page up or your camera down? Thank you.
About that. Focal diameter, ladies and gentlemen, would still be equal to 4 times the absolute value of p. All right, so that's for a parabola that opens to the right. Notice again, I do apologize, I forgot the page was down. Y is being squared instead of x for the parabola that opens to the right. That'll also be the case when the parabola opens to the left. Y is squared. So for the up-down parabolas, x is squared, y is to the first power. For the right-left parabolas, y is squared, x is to the first power. Okay. Notice everything else remains the same. Vertex point is still hk. Still got a lattice rectum. Focal diameter is still the length of that line segment. Axis of symmetry is still perpendicular to the directrix. It's just that now the directrix is vertical and the axis of symmetry is horizontal. That's the only difference. So that's all the information surrounding in a right opening parabola. All right. So the vertex point would be the leftmost point on the graph. Can't call it a minimum point or a maximum point anymore because this graph opens to the right, but we say it's the leftmost point on the graph. Okay, the vertex point. Okay, that's for a right opening parabola. The only other one is what? One that opens to the left. And so we'll look at that next. Let me know when we all have this accounted for. Are we all good on that? Anybody else need to have this up there still? Are we good on this? Okay. Let's look at a parabola that opens to the left. Your axis of symmetry is still horizontal. Your directrix is still vertical, but your directrix would be over here. Notice your focal point is always tucked inside the branches of your parabola, whether it opens up, down, right, or left, doesn't matter. Focus is always inside the branches. The directrix is always outside of the parabola. Notice that. This is your directrix. Standard form equation would still be the same. Be y minus k quantity squared is equal to 4p times x minus h. That's the standard form equation for a parabola that opens to the left. But now, ladies and gentlemen, p would be not greater than 0. P would be negative. P would be less than 0 for a parabola that opens to the left. Negative. Your vertex is still the ordered pair hk. Nothing has changed with that. Your focus is going to change a little bit now. Your focus, since your parabola opens to the left, is going to be h plus p Okay. Your directrix, it's going to be a vertical line. It's going to be x equal to h minus p. That would be the equation of the directrix. The axis of symmetry is a horizontal line, and therefore its equation would have to be y is equal to k. And the focal diameter is still twice the is going to be the length of the lattice rectum here, which is going to be 4 times the absolute value of p. All right, and p is still the distance between the vertex and the directrix, and between the vertex and the focal point. Nothing changes. P is still that, but p is negative now for this one. All right, so those are all the equations surrounding the different parabolas you can encounter. Those that open up or down, or right or left. Okay. So what's the main difference between those that open up or down versus right or left? What's the difference between the equation? What was that again?
The y value is squared instead of the x value for the ones that open left or right.
All right, so for the parabolas that open up or down, it's the x variable that's squared, not the y variable. And for the parabolas that open to the right or left, it's the y variable that's squared, ladies and gentlemen, not the x variable. So that's how you differentiate between the two. So the ones that open to the right have the x variable, open up or down have the x variable that's squared. And those that open right or left have the y variable that's squared. In both cases, you always have 4p times the linear variable, the variable raised to the first power. Notice that, okay? So it's a matter of differentiating the two equations and trying to remember the difference between them. And that's how you remember the difference. That's how I always remember the difference, is the x variable squared for up down ones, the y variable squared for right left parabolas. All right, let's see if we can go to our textbook here. Yeah, we have high winds here. And I think the winds are kind of playing heck with some of the lines out there, and cable lines are no exception, in addition to power lines. So hopefully we can finish this session with no problem. I would not want to be out on the Great Lakes today in a rowboat. Would you want to be in the middle of Lake Superior on a rowboat today, ladies? That wouldn't be too cool. All right, so we're going to go to our textbook now, and we're going to go to page 676. 676. So this gets us into our problems for section 7.3 involving a parabola. As always, ladies and gentlemen, feel free to look at the examples. Your author does a pretty good job in your textbook of laying out the examples in color too. So that's really appealing. You got things in nice color here. This is just explaining everything I just went over. Okay. So if you missed it, it's all in the section here. All right. So it's not like, you got a total loss if you did not get my notes here. And you can watch this video over and over again if you missed something or got to fill in some details. All right, let's just go down and see if we can do a couple of problems here. Problem number 16. For these problems here, it says A, determine the value of P. B, identify the focus of the parabola. C, write an equation for the directrix. Okay. All right, so it really comes down to is just knowing the equations, the different forms for the different parabolas. That's ultimately what it's going to come down to. And that has been the case for the other conic sections. So problem number 16, we have an equation of a parabola. We have a quadratic equation, x squared equals 12y. And I have a question for you. Ladies and gentlemen. What type of parabola are we looking at here? The up-down or the right-left variety?
Up, down.
Yeah, because x is being squared, this has to be the up-down parabola family, not the right-left. To hammer this into specific standard form, we would have x minus 0 squared is equal to 4 times 3 times y minus 0. This equation now is in standard form. It's in the form of x minus h quantity squared equal to 4p times y minus k. So, ladies and gentlemen, you can clearly see that this is a parabola that opens up or down. Specifically, what is p? What's my p equal to?
3.
3. Okay, because 4p must be equal to 12. So look at it this way. 4p has to be equal to 12 here, which would imply then that p is equal to 3. And since 3 is greater than 0, would this parabola open upwards or downwards?
Open upwards.
It's going to open upwards. So that would render the vertex point as being a minimum point down here. That's your vertex point. So what would p be equal to? Well, we already determined that. It's 3. What would be our focus in this case? Well, since the parabola opens upwards, your focus is going to be, higher than the vertex point, and your directrix is going to be horizontal down here. This would be your directrix, and your focus is going to be up here. So we know the distance between the vertex and the focus is going to be p. Your vertex point is going to be what? What is my vertex point? It's hk. So it would be the origin, 0, 0, 0, 0. So the focus, in order to move from the vertex point to the focus, the y coordinate has to increase by p. So the focus is going to be hk plus p, which gives us 0, 0 plus 3. So therefore 0, 3, ladies and gentlemen, would be the focus of this parabola, 0, 3. That's the focal point. I think they want the equation of the directrix being a horizontal line. The directrix is going to be y equal to the y component of the vertex decreased by p. So it'll be equal to hk minus p, which is going to be 0, 0 minus 3. So 0, negative 3. Well, this is, hold on, that's not an equation there. The equation of the directrix is y equal to the y coordinate of the vertex point decreased by p. So y would have to be equal to 0 minus 3, which is saying y equals negative 3. So y is equal to negative 3 is the equation of the directrix. So that would be the equation of your directrix, y equals negative 3. All right. And the parabola opens upwards. Okay. And if we wanted to sketch the graph, we could do that really easily. We know that the vertex is at 0, 0, and the parabola opens upwards, so you can just sketch the graph opening upwards. That'd be a rough sketch. All right, so that's a problem like number 16. One like number 22. Same thing. They want you to identify what P is, what the focus is, and what the equation is for the directrix. So for 22 here, we have negative 3x equals y squared. And so would this be an equation of a parabola that opens upwards or downwards, or right or left? What do you think? Up, down, or right or left variety?
I would say up.
Well, now the y variable.
Oh,
is
yeah.
square, right?
That would be left, right?
Yeah, it's going to be a parabola that opens to the left. To put this in standard form here, we could spin the equation around, and when you spin the equation around, it'll look like this. And therefore, now in standard form, it's going to be y minus k squared is equal to 4 times p times x minus h. That's standard form for your equation. And to put this into standard form here, you would have y minus 0 squared is equal to, now notice 4p has to be equal to negative 3. So 4p is equal to -3, which implies that p would have to be equal to -3/4. That's what p has to be. And notice p is less than 0, so the parabola definitely will open to the left. So continuing on with our standard form, we got 4 times -3/4 times x minus 0. So what would be the vertex? It'd be the ordered pair 0, 0 again. The focus, to move from the vertex to the focus point, focus being tucked inside the branch as always, to move from the vertex point to the focus. Since p is negative, we would just have to add p to the x coordinate to get the focal point. So the focus is going to be h plus pk, which means the focus is going to be 0 minus 3/4, 0, which is -3/4, 0. That's the focus. The directrix would be out here. It would be a vertical line now. So now your directrix is vertical. And so the equation of the vertical line would be x equal to something. And x would have to be equal to what? Well, x would have to be equal to the x coordinate of your vertex point increased by p, by a positive p. So x is equal to h minus p. So that implies the equation of your directrix is this vertical line, x equal to 0 minus a -3/4. That implies x is equal to +3/4. That would be the equation of your directrix. X equals 3/4. Okay. So now we've answered all those questions for that parabola there. Any questions how we found the focus, found p, and also found the equation for the directrix? Does that make sense, Larry Dillon? Does that make sense for that one? Any questions about these problems here? All right. Now, to apply parabolas, they have quite a few applications actually in the real world. Number like 26 here. It says a cross section of a parabolic mirror in a car headlight is modeled by y squared equals 12x. Where should the bulb be placed? Well, how does a parabolic mirror in a car headlight help things? Well, I can show you a picture as to what's going on here. On page 669, one of the examples, page 669, one of the examples here, they show you basically, ladies and gentlemen, how a car headlight works. Behind the bulb, you have a parabolic mirror in your car headlight. And that bulb lights up, and when that bulb lights up, it sends rays of light that strike the parabolic mirror. And no matter where these rays of light strike the mirror, they're always then directed into parallel beams outward from the parabolic mirror. And so, ladies and gentlemen, when you turn on your headlight on your car, this light bulb's rays strike the parabolic mirror behind the light bulb, and then the rays are directed down range on the road in a coherent straight beam of light. You see that there? So they use a parabolic mirror to take care of that business. That's one area among many areas where parabolas actually have real life applications. So the light beam of your light bulb in your car headlight becomes a coherent parallel beam of light made possible by this parabolic mirror. Well, that's all they want you to do with this problem now in problem number 26 here. They want you to, using that idea, they want you to answer this question down here. It says a cross section of a parabolic mirror in a car headlight is modeled by y squared equals 12x. I'm going to write that equation down. Where should the light bulb be placed so that its rays will become straight line rays and form a coherent beam of light that will be cast on the road ahead of you? Well, I have a question for you. What kind of a parabola is this going to be? Up, down variety or right, left?
Right, left.
Right, left. And it would be y minus 0 squared is equal to 12 times x minus 0. Where this is now in standard form, y minus k squared is equal to 4p times x minus h. Where 4p is equal to 12, which renders p being equal to 3, which is greater than 0. So that means this parabola would have to open to the right. So, ladies and gentlemen, we have a parabolic mirror in your headlight that opens to the right. Here's your headlight here, your headlamp. And then you have a light bulb. Okay, you got a bulb here. And they want you to indicate where you need to place this bulb so that when you turn on this lamp here, this light, the rays emanated by that bulb are going to strike the parabolic mirror and then be sent downrange as parallel beams of light. Parallel beams of light. Made possible by the parabolic mirror that they're reflecting off of. You see that there? That's how headlights work here. Pretty cool, huh? How the parabolic mirror makes these light rays from your bulb become coherent as one coherent beam of light sent down the road. And so this would be, the front of your car here. All right. There's your wheel, correct? There's your headlight. Pretty neat, huh? All right, they want you to determine where you're gonna have to put this light bulb. So ladies and gentlemen, what we have to find is we have to find P here. In relation to the vertex point, we got to find what P would be. Well, P is going to be equal to 3. Do you agree? And so my guess is that this light bulb would have to be placed 3 inches. Was it inches? Did they say inches or centimeters? Or I would think it has to be 3 inches. 1, 2, 3. Yeah, it seems like it'd be about 3 inches. You'd have to place the light 3 inches on the axis of symmetry to the right of the vertex point. That's where the light bulb would have to be placed, somewhere right here, 3 inches away from the vertex point, in order for its beams to be coherently reflected down the road. If you put the light closer than 3 inches or further away than 3 inches from the vertex point, then these beams of light will not be reflected coherently straight down the road. Okay, then you're going to have a problem. And so, yeah, you'd have to place the light 3 inches to the right of the vertex point. That would be your answer. Okay. So the light bulb must be placed 3 inches to the right of the vertex point. And there you go. That's one area where parabolas can be used. And again, how did we get 3? Well, because we know 4p has to be 12, and therefore p has to be 3. So a parabolic mirror used in your headlamps. Any question about that problem? So again, your light bulb would have to be 3 inches to the right of the vertex point. Here's the vertex point, and the lamp would have to be right there, 3 inches to the right. So that's where the manufacturer is going to put the headlamp. All right. Like number 32. Now, what do they want us to do with these problems here? Well, for problem 32, they want us to identify the vertex, the value of P, the focus, the focal diameter of the parabola, identify the endpoints of the lattice rectum, graph the parabola, write equations for the directrix and the axis of symmetry. In other words, they want you to do everything. So they want all the information surrounding this parabola. So let's go look at number 32. In fact, ladies and gentlemen, we can probably turn this into classwork number 1. Today is the 6th day of December. Tomorrow, December 7th, is the memorial of World War II. What event occurred during World War II? December 7th, 1940. Was it
Pearl
41?
Harbor.
Yeah, December 7th, 1941, I believe. Is that correct? Well, I believe it was 1941. Is that correct, or am I wrong? Anyways, it's the memorial of the bombing of Pearl Harbor by Japan back in World War II. That was a surprise attack on a Sunday morning. All our sailors were still sleeping after maybe a hard night of partying on Saturday night. I don't know. And then Japan snuck a sneak attack on us. December 7th, I think it was 1940. I want to say 41. Anybody know differently out there? Or?
I believe it is.
I think, that's what rings in my mind. 1941, December 7th. Okay. But yeah. Yeah, many years ago, but that did happen. Bizarre. All right. So let's see if we can, try to get a handle on this problem. Ladies and gentlemen, this is not standard form. It's close to standard form, but I have to get x squared by itself. So what do I do with the 2 here?
Divide by 2.
So let's divide both sides of the equation by 2. So therefore, x squared is equal to 7y. Now let's hammer this into more specific standard form. So we got x minus 0 squared is equal to 4p. Well, is equal to 7. 4p is equal to 7, right? But I'll just put 7 here for now. So 7, and that's going to be equal to y minus 0. Let that dry there, so I'll put a 7 in there. So therefore, my 4p has to be what? 7, right? That's 4p, which has to be 7. I did it again. I put 4p in there. It's supposed to be 7. Anyways, that implies that p is equal to 7 fourths. So p is greater than 0. So is this parabola going to open to the right, left, up, or down? What's going on here?
It'll open up.
Yeah, it's the up-down variety since x is squared and y is not squared, and p is greater than 0, so it's going to open upwards. What I would like you to do is, using this equation here, ladies and gentlemen, knowing that p is 7 fourths, let's see if you can answer all the questions they're asking us here. In other words, what would be the vertex? What would be the focus of the parabola? What would be the end points of the lattice rectum? No, actually, I don't think I gave you those formulas for the endpoints of the lattice rectum. I guess I forgot to write those down. So maybe we'll just work on this one together here. So maybe this is not classwork 1. So we'll cancel classwork 1. This is not classwork 1. Anyways, let's see if we can get a feel on this. What would be my vertex point? It's going to be HK. So it would be what? 0, 0, the origin. There's the vertex at the origin. P is equal to 7 force. Parabola opens to the right. And you know what would opens upwards? Excuse me. Parabola opens upwards. You know, by drawing or sketching getting a visual on this by sketching a graph really helps immensely. Really orients your thinking. So there's the vertex at the origin. Remember, the focus is always P units away from the vertex point. So my focal point is going to be P units. The directrix in this case would have to be horizontal. That's the directrix, and it is P units away from the vertex point. The axis of symmetry contains the focus and the vertex and is perpendicular to the directrix. This would be your axis of symmetry. All right, so let's see if we can find a couple of these things here. What would be the focal point? Well, since P is positive, to move from the vertex to the focal point, what coordinate has to increase by 7 force?
Y.
The Y coordinate, correct? Because that you're moving along a vertical here. Yeah, the X coordinate's stuck at 0, but the Y coordinate has to increase by 7 force, because that's what P is. So the equation of your focus point is going to be 0, 0 plus 7 force, or 0, 7 force. That would be your focus point. 0, 7 force. Now your lattice rectum goes right through the focus point and picks up 2 points on the parabola. They want the endpoints of the lattice rectum, and this endpoint here. To move from the focus point to the lattice rectum, what coordinate changes since you're moving along a horizontal?
X.
Only the X coordinate changes, not the Y coordinate. Since your focal point is 0, 7 force, to move from your focus to the left endpoint on the lattice rectum, the Y coordinate has to change, the X coordinate has to change by what? By how much? What was this length again here?
Wasn't it 2 times the absolute value of P?
2 times the absolute value of P. So that distance is going to be 2 times the absolute value of 7 force, and 2 times 7 force is 7 halves. So therefore, the left endpoint of your lattice rectum over here is going to have your X coordinate of your focus point, which is 0, be decreased by 7 halves. So this left endpoint of your lattice rectum is going to be 0 minus 7 halves 0, or it's going to be negative 7 halves 0. So that, ladies and gentlemen, would be the left endpoint of your lattice rectum, negative 7 halves 0. So what would be the right endpoint of the lattice rectum?
Wouldn't it be negative 7 halves and then 7 fourths? Because
Oh, yeah, the Y coordinate of the focus point is 7 fourths. That's correct. Yeah, I thought we were on the down by the vertex. We're not. That should be 7 fourths here. So negative 7 halves 7 fourths would be the ordered pair address of the left endpoint of the lattice rectum. So this would have to be 7 fourths. The right endpoint of your lattice rectum's endpoint, therefore, would have to be positive 7 halves and then 7 fourths. There you go. So those would be the endpoints of the lattice rectum, negative 7 halves, 7 fourths. And the right endpoint would be positive 7 halves, 7 fourths. All right, that's that. What else do they want? The equation of the directrix. Since the directrix is a horizontal line, it's going to be y equal to what? To move from the vertex to the directrix, what coordinate has to change, the x or the y?
Y.
Y coordinate changes, and it actually decreases because you're moving in a negative y direction, so it decreases by what, 7/4. So the equation of your directrix is going to be y equal to 0 minus 7/4, or y equal to negative 7/4. That would be the equation of your directrix, that horizontal line. Your axis of symmetry, what would be its equation? Well, your axis of symmetry is a vertical line and it goes through the vertex point. And so the equation of a vertical line is x equal to, and notice your axis of symmetry runs right through the vertex point whose x coordinate is 0. Therefore, the equation of the axis of symmetry is x equal to 0. That's your axis of symmetry. What would be the focal length, or the focal diameter rather? Should be saying focal diameter. That's 4 times the absolute value of p always. So that's going to be 4 times p is 7/4. So 4 times 7/4 is 7. That would be the length of your focal diameter, 7. That would be the length of your, basically your lattice rectum, which is going to be 7 units long. Right, 7 units. Okay. Let's see, was there anything else we had to answer for that question? I can't remember. There's so much we had to answer for it. It said identify the vertex, the value of p, the focus, focal diameter of the parabola, identify the endpoints of the lattice rectum, graph the parabola, write the equation, directrix, and axis of symmetry. We've done all that. We just have to graph this parabola. I think we're good. Okay. So we know quite a bit about this parabola. We know the vertex point is at the origin, 0, 0. We know the lattice rectum has a length of what? 7 units in length, right? So, and the lattice rectum contains the focal point, the focus being 0, 7/4. What's 7/4 for plotting purposes as a mixed number? 7/4 would be 1 3/4. So 1 3/4, 1 3/4. So ladies and gentlemen, your focal point would be right here about 1 3/4, 0, 1 3/4. And your lattice rectum's endpoints have to be positive 7/4 and negative 7/4 for the y coordinate, for the, I'm sorry, 7/2 and negative 7/2. 7/2 being 3.5. So that would go out to 3.5 out here. And negative 3.5 out here. So you could even put a little light little line through here. And therefore your parabola is going to have to come up here and grab those endpoints of the lattice rectum. It's going to have to go there. It's going to have to come up here and grab those. So that would be a graph of your parabola there. That opens upwards. Focal point, again, is the point 0, 7/4, which is 0 and 1 3/4. Here's the endpoints of your lattice rectum. Should be 7/2, which is 3.5. 1 3/4, and the left end point would be negative 3.5. 1 3/4. And there you go. There's the graph of your parabola there. And the directrix is y equals to what? Y equals negative 7/4, which implies y is equal to negative 1 3/4. So negative 1 3/4. So your directrix would be this horizontal line that goes right through here, the y-axis at negative 1 3/4. All right, there. That would be your directrix. Any questions here? How we graph that? And your axis of symmetry would be the y-axis. Do you agree? The y-axis would be the axis of symmetry. And the equation of the y-axis is x equals 0. Any questions how we answered that question there? All right, that was one like number 32. All right, so let's see now, ladies and gentlemen, I'll give you number 37 for classwork. What I want you to do is take that equation there. And, for problem number 37. And I want you to find the vertex point. Find the vertex. I want you to find the focus. I want you to find the equation of the directrix. The equation of the axis of symmetry. Endpoints of the lattice rectum. And then I would like you to graph the equation, okay? So that's for number 37. So the equation is x minus 1 squared equals -4 times y plus 5. All right, so see if you can do this problem. This is number 37 in section 7.3. This will be classwork number 1. All right. See if you can do all that. Okay. So solutions to classwork number 1. And again, this would be the graph of the parabola for classwork number 1. All right. Back to textbook here. Okay, so that one's good. One. Okay. Now notice, ladies and gentlemen, that these problems here, 45 onward, are not in standard form. They're all in what form? 45 through 49. They're all in general form. So the first thing we need to do is complete the square on the relevant variable to hammer these into standard form, these equations. And I wanted to demonstrate at least one. Yeah. So let's see if we can do problem number 49. We have 4x squared minus 28x plus 24y plus 73 is equal to 0. And what we want to do here is, once we write the equation in standard form, we want to identify the vertex, focus, and focal diameter. Well, to get this into standard form, we're going to have to complete the square on what variable, x or y? What do you think?
X.
Yeah, notice the completion of the square is going to have to be performed on only the x variable, not the y variable, because we don't have any y squared term in here. It's only the x variable, and it needs to be subjected to the completion of the square, because we have a second degree term in x and a first degree term. So to complete the square on x, what I'm going to do is, instead of dividing all terms on both sides of the equation by 4 to force a 1 in front of x squared, I'm going to factor out 4 out of the first two terms here. And that'll force a 1 in front of x squared. Next thing we can do is maybe move the constant over to the right side of our equation. And now we can complete the square on x. To complete the square on x, we add the square of half the linear coefficient to the binomial here. So that means we got to take half of -7 and we have to square that. But ladies and gentlemen, I added a new number to the left side of my equation, and the new number I added was 4 times -7/2 squared. So I have to add that number to the right side so I do not upset this equation or change it. All right. Now, continuing to simplify inside the parentheses here, we have x squared minus 7x. -7/2 times -7/2 is 49/4. We can now factor this perfect square trinomial we created through the completion of the square method. What did I square to get 49/4? -7/2. So this trinomial factors in x minus 7/2 times itself. Over here, we got -73. 4 times 49/4. The 4's cross cancel out, leaving you with 49. What's -73 plus 49? Well, let's see. That's going to give you 24. Is that 24? -24. Is that -24, ladies and gentlemen? I think it is, isn't it? Yeah, I think so. All right, now what we're going to do to get this in the standard form is we're going to have to move this y over to the right side. So we subtract 24y from both sides. We can now factor -24 out of both these terms here. Now I'll divide both sides by 4. And we will then have standard form. -24 divided by 4 is -6. And there we have it, ladies and gentlemen. We now have standard form. X minus h squared equal to 4p times y minus k. Everybody see standard form there? So what would be my vertex point? In hk, it would be what? H is -7/2 rather. And k is what? 1? -1. Careful here. K is -1. That would be your vertex point, 3.5, comma -1. What's p? Well, 4p is equal to -6, which implies that p is equal to -6/4, which implies that p is equal to -3/2, which being less than 0, this parabola would open what? Upward or downward?
Downward.
It would open downwards. Okay, so the parabolic graphs can open downwards. So the vertex point, 3.5, -1 would be rendered as a maximum point on the graph, the highest point on the graph. What would be so since the parabola opens downwards, just a rough sketch here, very rough sketch. Parabola opens downwards, focal points tucked inside the branches, the directrix runs out here. So ladies and gentlemen, what would be the focal point? How do I move from the vertex point to the focus point? What coordinate changes?
Y.
Only the y coordinate. And in fact, does the y coordinate increase or decrease from the vertex point to the focal point?
Decreases.
Decreases. Decreases by what amount? By p,
Yep.
which is -3/2. So therefore, the focus is going to have the same x coordinate as a vertex point. So the x coordinate of the vertex point is still going to be, of the focus rather, still going to be 7/2. But now the y coordinate goes from -1 and decreases further down by -3/2. So -1 plus p, which is -1 minus 3/2. So your focal point is going to be 3.5. And -1 minus 3/2 is -1.5. And that would be your focus point right there, 3.5, -1.5. So you know what, just by doing a rough sketch on your paper, ladies, I'm gonna help you to understand what coordinate changes from your vertex to your focus point. So it's very important just to do a rough sketch, okay? All right, and what would be the focal diameter? What would be the focal diameter? Well, the focal diameter is always going to have a length of 4 times the absolute value of P. So that's to say it'd be 4 times the absolute value of -3/2. So the focal diameter will be 4 times 3/2, which is to say 6. So the length of the lattice rectum would be 6 units in length. That'd be the focal diameter, 6. 4 times the absolute value of P, 4 times the absolute value of -3/2, 4 times 3/2, which is 12/2 or 6. That would be the focal diameter. That's the length of this lattice rectum from here to here. That'd be 12, that would be 6 units in length. Okay. 6 units in length. And then you could find the endpoints of the lattice rectum by just adding 6 to your x coordinate to go from the focus to the right endpoint, and then subtracting 6 to go to the left endpoint of the lattice rectum from the focus. Subtract 6 from the y coordinate. I'm sorry, not the y coordinate, the what? We're moving along a horizontal here. So the x coordinate changes by 6. So to go to the right endpoint of the lattice rectum, we add 6 to the x coordinate of our focus point, which is 3.5. So this right end point would be what? The x coordinate would go from 3.5 and you'd add 6 to this. So it'd be 9.5 and -1.5. That's the right end point. The left end point of the lattice rectum would be taking the x coordinate of your focus and subtracting off 6. So what's 3.5 minus 6? Well, that would be negative what, 2.5, I believe. 2.5.
Wouldn't it be -3 because the whole length of the lattice rectum is 6?
Whole length of the lattice rectum is, yeah, so half this distance would be just what, 3. All right. All right, so to get the right end point of our lattice rectum, we add 3 to the x coordinate of the focus point, only 3. So the right end point would be 3.5 plus 3, which would be 6.5. So 6.5, -1.5. And the left end point of the lattice rectum would be taking the x coordinate of the focus and subtracting off 3 units. So 3.5 minus 3 would be what? Would be 1/2, correct? 1/2, -1.5 would be the left end point of your lattice rectum. Okay. Yeah, the length of the whole lattice rectum is 6, so half the length is 3. Okay, so you're only moving 3 to the left of the focal point or 3 to the right from the focal point to identify the endpoints of the lattice rectum. Okay. And then, you would have enough information to then graph that parabola there. But the main thrust of this problem is completing the square on x. Any questions how we completed the square on x, ladies and gentlemen? Does that make sense? Completing the square on x. All right. Completing the square on x. Notice these other ones, 45 through 48, are a lot easier to complete the square on x or y because you have 1 in front of the squared variable. So I chose a difficult one, number 49. I wanted to show you what happens when you don't have 1 in front of your squared variable. Well, I factored the 4 out of the first 2 terms in 49 to force 1 in front of x squared. But notice all these other ones have 1 in front of the squared variable here, which really makes life a lot easier in completing the square. All right. So does that make sense how we completed the square there on that one? Do you think you could complete the square on any one of those other ones? You want to see another one done, or is that good enough, ladies and gentlemen? for completing the square. Putting them in the standard form. Anybody want to see another one done? All right, if not, I will assume we're good. Let's jump down to number 62. Now they're going to give you some information about a parabola, and they want you to determine therefore, from the information, they want you to write the equation in standard form for the parabola. And notice they give you different information. For like number 62, they give you the vertex and the directrix. And from that, ladies and gentlemen, that should be enough information to write the equation of the parabola. Maybe we better try one or two of these. So number 62, they give you the vertex is 0, 0. And they give you the directrix equation is what? Y equal to -2. What do you think I need to do? What did I do with all the other problems with hyperbolas and ellipses to write their equations? What did I do, ladies and gentlemen? I took the given info and did what with it? Anybody remember? What's going to facilitate our ability to write the equation of this parabola? Take the given information and do what? We're going to have to get some sort of a visual on this. Do you agree? So what I would recommend you do is take the given info and then try to, do a rough plot of this info so that we can see what we're up against here. Well, we know the vertex is at what? The origin, correct? And we know the directrix is y equals to -2. Is this going to be a horizontal or vertical line for the directrix? Horizontal or vertical line? Well, since it's y equal to -2, it's going to be a horizontal line. We know the vertex is at the origin. We know our directrix goes right through the y-axis down here at y equals -2. And therefore, this parabola has to open upwards, downwards, right or left. What do you think, based on where the vertex is and where the directrix is? What do you think, ladies and gentlemen? Emma, if your life depended upon it, would this parabola open upwards, downwards, right or left? What would be your guess?
Down.
Okay, you're saying downwards. All right, let's hold on here. Let's analyze this now. You're saying downwards. Did our parabola ever go through a directrix? Ever? The directrix is up here. Did our parabola ever go through a directrix?
No.
Never, it never did it? The directrix is always outside the parabola, and the parabola always opens away from the directrix. Notice that. Always opens away from the directrix. Okay. So, okay, you care to edit your statement there? Would this parabola open upwards, downwards, right or left? What do you think?
Upwards.
It has to go upwards. It cannot go to the right. If it goes to the right, the parabola goes through the directrix. If it goes downwards, parabola goes through the directrix. If it goes to the left, parabola goes through the directrix. It has to open upwards. It has no choice. So it's got to open upwards. Got to do this number. Okay. Now we have a visual on this. That's really going to orient our ability to write the equation of this parabola. Okay. So now we're moving in the right direction. So what equation am I shooting for? Which variable would have to be squared since this parabola opens upwards? The y or the x variable? Y or x? What do you think?
X.
Yeah, the x variable has to be squared. So this is the form we're shooting for right here. So that would be the form we're shooting for, ladies and gentlemen. Now we just have to populate this equation and we got it. Well, we know the vertex is the ordered pair HK, and they told us that's 0, 0. So we know 0 goes in for H, 0 goes in for K. Got that. We just need to find what P is. Anybody remember what P is? P is what distance?
The length between the vertex and the directrix.
Yeah, it's the length, the perpendicular distance between the vertex point and the directrix, or the perpendicular distance between the vertex point and the lattice rectum, if you will, or the focus point. Okay. So look at, we can find this distance, can't we? What distance is the vertex away from the directrix? If the equation of the directrix is y equals -2. What point would this have to be down here on the y-axis? What point is this?
-2.
0, -2, exactly. So what is P, ladies and gentlemen? Positive or -2? The parabola opens upwards.
+2.
Yeah, P has to be +2. Okay, because our parabola opens upwards, it has to be a positive, not a negative. All right, here's your equation of your parabola. X squared is equal to 4 times 2 times y, or x squared is equal to 8y. Ladies and gentlemen, there's your answer. That is the equation of the parabola whose vertex is at the origin and the directrix is at y equals -2. That's your equation. You see the analysis that was poured into that problem. Always get a visual on things, ladies. I'm always do a rough sketch and get a visual. Otherwise, you're not going to even know what equation you need to lean towards. Okay, that's true for hyperbolas, ellipses, and parabolas. Always get a visual on things. All right. So classwork number 2, ladies and gentlemen. I want you to do problem number 64. They give you the focus is 5, 3 and the vertex is 3, 3. Write the equation of that parabola in standard form. Number 64, classwork number 2. Go ahead and do that problem. They give you the focus, they give you the vertex. That should be enough to write the standard form equation for that parabola. Hint, how do we get started? How about plot the points and get a visual on what's going on? There you go. Okay, ladies and gentlemen, if you just plot the information on the graph, you can get a visual on this. The focus is at 5,3, the vertex is at 3,3. And notice the branches of the parabola always contain the focal point. So this parabola has to open to the right, has no other choice. P is going to be 2, the distance between the vertex and the focus. And so therefore, since it's a parabola that opens to the right, the equation we're shooting for is for y to be squared, not x. So this would be the standard form equation that we're aiming for. The vertex is 3, 3, so k and y and h would be 3. So we have y minus 3 squared. P is 2, so 4 times 2 times x minus 3. And therefore your equation would be y minus 3 squared is equal to 8 times x minus 3. Did anybody get that correct?
Yes.
And that'd be your answer. Okay. So always try to get a visual on information that's given to you for a conic section. Plot the information, do a rough sketch, a rough graph, and then by knowing and seeing what's going on, then you lean towards the appropriate equation that you're trying to write. And then it's just a matter of filling in the details in the equation. And so that would be the answer. All right, I believe I have to also make available for you a quiz on chapter 7, I believe. Is that correct? Alex, chapter 7 quiz, which will cover circles, ellipses, hyperbolas, and parabolas, conic sections. I will post that quiz, and today is Monday. Let's see. All right, and I will post that quiz. Today is Monday, so let's see here. I won't be able to post it. So let's see, Tuesday, Wednesday, Thursday. So we can make that quiz due by I'll give you to like Friday midnight. I'm going to get that quiz done for chapter 7. You think that's going to be enough time? Friday midnight. Chapter 7 quiz on Alex. You think that should be enough time, ladies and gentlemen?
Should be.
All right, I'll give you to midnight.
I think so.
Friday night, midnight for the chapter 7 quiz on Alex, okay? And again, that's going to cover conic sections, circles, ellipses, hyperbolas, parabolas. And I will update the homework for section 7.3. Try to always do the homework, before you dive into a quiz and before you dive into an exam. Always do the homework first, because it's through the homework that you gain an understanding as to what's going on. And the nice thing about homework is that you can do it as many times as you want. And so you can get as much practice as you can possibly fathom on homework, all right? And you can look at examples too, although I have opened up that feature for exams and quizzes where you're able to view an example if you get stuck on a problem, which is kind of in all honesty, is kind of a lucrative thing that I've allowed. Because normally on quizzes and exams, you're not supposed to look at any examples. So I did kind of stretch there a little bit there, ladies and gentlemen, for you. But we'll make that due on Friday night by midnight for the chapter 7 quiz, okay? Any other questions, ladies and gentlemen? So again, just remember that there is no class on Wednesday, December 22nd. Officially, the semester comes to an end on the 20th. I will allow you to, complete the final exam, however, and get it to me as late as midnight, December 23rd, though. Being an online class, you have that luxury of being able to do that, okay? But technically, the semester is gonna come to a close on the 20th of December. So we will not meet on Wednesday, December 22nd. So just make that little change. Other than that, there really is no other change that's necessary. Well, have a good night. Hopefully I'll see you in a couple days.
I just had a question. I noticed on my homework I got like a 56 out of 100 on it, but I don't know how, but I have two of them that are 0% on it, but I don't.
Well,
It
which
looks like
homework,
they-
which homework was that?